Good morning. With this video, we are finishing our the first module, that means halogen compounds. And in this class, we are discussing about distinction between nucleus and side chain halogenated hydrocarbons. Side chain halogenated hydrocarbons. How that means how will you distinguish between, see, when the halogen atom is in the nucleus, that means here the halogen atom is directly attached to the ring. That means you can say that the halogen atom is attached to the nucleus. And how do you distinguish between nucleus and side chain halogenated? This is nucleus. And what do you mean by side chain halogenated? That means here it is CH2X. CH2X. Now you can see that here the halogen atom in the side chain. Here you can see that the halogen atom is in the nucleus. How will you distinguish between these two? That is what is we are discussing in this video. Distinction between nucleus and side chain halogenated hydrocarbons. Okay, look at here. Before that, we know that this aryl halides, these are aryl halides, aryl halide, and these are alkyl halide, alkyl halide. Okay, alkyl halide means halogen atom is in the nucleus, and aryl halide means hydrogen atom is in the halogen atom is in the side chain, and aryl halide means halogen atom is directly attached to the nucleus. So this is aryl halide, and this is alkyl halide. Halogen atom is in the side chain, and we know that the aryl halides are less reactive towards nucleophilic substitution reaction. Aryl halides are less reactive towards nucleophilic substitution reaction, but alkyl halide, this will give nucleophilic substitution reaction at a better rate. When you compare the nucleophilic substitution reaction rate of aryl halide and alkyl halide, you can see that this alkyl halide will undergo nucleophilic substitution reaction at a better rate. This rate difference only we are considering in order to distinguish between aryl halide and alkyl halide. Okay, look at here. You can see that with one reaction we can distinguish between these two. That means a reaction with alcoholic silver nitrate, AgNO3. First we are taking alkyl halide. That means we are taking benzyl chloride, CH2Cl. This is side chain halogenated hydrocarbon. This is benzyl chloride. Okay, benzyl chloride. Then it is reacting with alcoholic silver nitrate. That means silver AgNO3 in presence of ethanol, C2H5OH. Okay, look at here. What is the mechanism of the reaction? First step one. You can see that you look at here, CH2Cl. Okay, in presence of nucleophile C2H5OH, in presence of our nucleophile ethanol, you can see that this reaction will is occurring via SN1. That means the first step is the formation of carbocation CH2 plus, what will be eliminated Cl minus via SN1. The reaction is proceeding via SN1. The first step is the cleavage of CX bond. We are getting this CH2 plus. That means carbocation is formed. Okay, that will be there, and the nucleophile will come and attack here. Okay, that is there. Now we are here discussing another factor. You can see that this Cl minus is here. Now in our solution, silver nitrate is there. AgNO3, silver nitrate plus Cl minus, thus the Cl minus which is removed from the carbon atom, this Cl minus is reacting with the silver nitrate and will form what will form AgCl, silver chloride AgCl plus what will form NO3 minus, NO3 minus. And look at it here, instead of suppose here I am taking, instead of a particular example, if I am taking CH2X, what will be removed, X minus will be removed, and what you will get here it is X minus, and here you will get AgX. Okay, let it be silver halide. We are getting silver halide, precipitate of silver halide. We will get precipitate of silver halide. And suppose if X is, this X is Cl, okay, X is Cl, then what is that? Ag, what will form? AgCl will be formed. This is white PPT soluble in NH4OH, ammonium hydroxide. White PPT soluble in NH4OH. That means if you take benzyl chloride CH2 here, if it is Cl, then what you will get? We will get AgCl. And if it is Br here, what you will get? If X is Br, what you will get? We get AgBr. AgBr is pale white, okay, or pale white, or you can write it as pale yellow, you can write pale yellow, and partially soluble in ammonium hydroxide. If X is equal to I, if X is I, what will form? AgI will form, and it is yellow in color, and it is insoluble in NH4OH. Okay, insoluble in NH4OH. So once again, repeating this one, we are taking side chain halogenated hydrocarbon, benzyl chloride we have taken. Benzyl chloride is treated with alcoholic silver nitrate. Okay, if we are taking benzyl chloride, what will form? You will get silver chloride, and it will form a white precipitate soluble in ammonium hydroxide. If here it is bromine, we get AgBr, that is pale yellow, partially soluble in ammonium hydroxide. And if here it is I, we will get AgI, and it is yellow in color, and it is insoluble in ammonium hydroxide. Now, instead of this side chain substituted halogen, if you take halogen atom in the nucleus, halogen atom is in the nucleus, that means if you take chlorobenzene, chlorobenzene, again the same reaction condition, AgNO3 in presence of ethanol, no PPT, that means no reaction, that means there is no reaction, so it cannot undergo this type of reaction, and there is no PPT. That means from this it is very clear, if you are getting a precipitate, you can say that is a side chain halogenated hydrocarbon. If you are not getting any precipitate, you can say the halogen atom is in the nucleus. This way you can distinguish between side chain substituted halogen hydrocarbon, as well as halogen atom is in the nucleus. And now, uses of some halogenated hydrocarbons. Uses of some halogenated hydrocarbons. First one, number one, chloroform. Formula CHCl3. First use, chloroform. It is used as a solvent for fat, rubber, etc. Fat, rubber, etc. Second one, as an anesthetic agent. anesthetic agent, and third one as a preservative for anatomical specimens. Okay, so first one is the use of some halogenated hydrocarbon. First one is chloroform, CHCl3. It is used as a solvent for fat, rubber, etc. As an anesthetic agent, and the third one as a preservative for anatomical specimens, and it is used for the preparation of freon refrigerant. Another use is for the preparation of freon refrigerant. That is the first one, chloroform. The tetrachloride, carbon tetrachloride, CCl4. Again, carbon tetrachloride is also used as a solvent for rubber, fat, etc. Second one, it is used in fire extinguishers under the name pyrene. When carbon tetrachloride is used in fire extinguisher, it is known as pyrene. Okay, pyrene. And then next use is it is for used for degreasing in dry washes. And it is used as a cleaning liquid. These are the uses of carbon tetrachloride. First one is it is used as a solvent. The second one is it is used in fire extinguishers under the name pyrene. Third one it is used as a degreasing agent in dry wash, and in the last one it is used as a cleaning liquid. And of course this carbon tetrachloride is highly toxic in nature. It can affect, it may cause irritation to our skin, it may cause giddiness, sometimes it may cause our nerve cells, liver, etc. And one other important factor is this carbon tetrachloride is causing a depletion of ozone layer, so harmful ultraviolet light can come to the troposphere or our Earth atmosphere, and that UV rays may cause skin irritation, skin cancer, sunburn, etc. So this carbon tetrachloride is highly toxic.